Hi, my name is Gia. In this video, I will discuss an example about how to use a strong mathematical induction to prove some property. Okay, so for the strong induction example, here let's say that we have an, where an is 1 if n is equal to 1, an is 3 if n equal to 2, and an is an minus 2 plus 2 an minus 1 for n is 3, 4, 5, and so on. And we want to prove that an is always an odd number if n is larger or equal to 1. See that this is a recurrence relation where an is related to an minus 2. So we move 2 to the back, not only 1. It means that we need strong induction for that. Because let us think about pj plus 1. Pj plus 1 will be related to an plus 1. And an plus 1 will be related to an minus 1. So an will not enough to prove pj plus 1. Okay, so here we will use strong induction. And let's say Pn is what we want to prove. That is, An is 2k plus 1 for some integer k. This is what we mean by odd numbers. Right. And the first step in mathematical induction, as usual, we have the proof of the base case. And because this is strong induction, where we move 2 to the back, it means at least we will need 2 numbers in the base case. Okay, and here, because we want to prove for n at least 1, then we will prove for n is 1 and n is 2. N is 1 means that an is 1, a1 is equal to 1. And it is 2, we can write it as 2 times 0 plus 1, which is exactly what it is, where k is equal to 0. It's 2 times some integers plus 1, which means it is odd number. And for a2 is 3, which is an odd number. Or we can write it as 2 times some integer plus 1. So we can say that P1 and P2 hold. The next step, we want to have some induction hypothesis. So here, because we have strong induction, for some j larger or equal than 2, we will assume that for P1 and so on until Pj, they are hold. That is, these all hold. Okay, why 2? Because we have proven P2. That is why we have 2 here. And why from P1? Because what we want to prove starts from 1. Okay, so this is the induction hypothesis. And next, induction proof. As before, we want to prove that Pj plus 1 holds for the same j we have here. So here we want to prove that aj plus 1 is equal to what we have here. So aj plus 1, we can start from there and use the fact we have in the assumption that P1, P2, and so on until Pj holds. That is, the A1, A2 until Aj can be written as 2 times some integers plus 1. So here, Aj plus 1 from the definition of An, we can see here, An is An minus 2 plus 2 times an minus 1. So here, aj plus 1, we can write it as this, as the definition of an. And then aj minus 1 is 2kj minus 1 plus 1. It is from the induction hypothesis, because here we have this. Imagine we have aj minus 1 here, okay? And then aj can be written like this from the induction hypothesis as well. So from this, we can write it like this, and like this. And because kj minus 1 and kj are integers, it means this always be integers. So this is 2 times some integer plus 1, so that we can say that aj plus 1 is odd number as well. So it is proven that aj plus 1 is also an odd number. Okay, that is for the example for strong mathematical induction. And the next video will discuss about common mistakes usually occur when we prove something with mathematical induction. Okay, thank you for listening and see you in the next video.